Hello and welcome back at the Finite Link channel. For those who are new in this channel, please don't forget to subscribe and hit the notification button for the new videos that will be uploaded. So with this video, we have come to the final module in the Switching, Routing and Wireless Essentials course. And this course gave you in-the-depth knowledge and skills you need to set up switches and routers, including even wireless devices on your growing network. So it means that now you are really good at network administration. But what makes a good network administration into a great one is the ability to effectively troubleshoot. And the best way to gain network troubleshooting skills is so simple. Always be troubleshooting. Here in this material, we will troubleshoot both static and default routes. So we will explain how a router processes packets when a static route is configured, and then we will troubleshoot common static and default route configuration issues. Before diving into the troubleshooting portion, let's provide a brief review of how packets are forwarded in the static routes. Here we have a figure where there will be an animation and how PC1 will send a packet to the PC3. Let's first explain the steps and then we will show you the animation. So the packets from PC1 will have 000 interface of router 1. Router 1 does not have a specific route to the destination 192.168.2.0/24. Therefore, router 1 uses the default static route. Router 1 will encapsulate the packets into a new frame. Because the link to router 2 is point-to-point link, router 1 adds an all-once address to the layer 2 destination address. The frame is forwarded out of the serial 010 interface of router 1. Then the packets arrive on the serial 010 interface on the router 2, where the router 2 then will de-encapsulate the frame and look for a route to the destination. Router 2 has a static route to the network 192.168.2.0/24 out of the serial 011 interface. So the router 2 what we'll do, we'll encapsulate now the packets in the new frame and because the link to the router 3 is point-to-point link, he also will add all-once address to the layer 2 destination address. The frame now is forwarded out of the serial 011 interface. When the packet arrives on the serial 011 interface on the router 2, here as a router will encapsulate the frame and looks for a route to the destination. Router 3 has a connected route to the network 192.168.2.0/24 out of the Giga Ethernet 000 interface. So router 3 looks up the ARP table entry for the 192.168.2.10 to find the layer 2 media access control address, the MAC address for the PC3. If no entry exists, router 3 sends an address resolution protocol request out of the Giga Ethernet 000 interface, and the PC3 responds with an ARP reply, including the PC MAC3 MAC address. Then router 3 encapsulates the packet into a new frame with the MAC address of the Giga Ethernet 000 interface as the source layer 2 address and the MAC address of PC3 as the destination MAC address. The frame is forwarded out of the Giga Ethernet 000 interface. The packets arrive on the network interface card of PC3. So all of this is explained here in this animation by the packet that is moving through the network to reach the destination. And Remember this, no matter how well you set up your network, you will have to be ready to troubleshoot some problems. Networks are frequently subject to events that can cause their status to change. For example, an interface can fail or a service provider drops a connection, links can become oversaturated, or an administrator might enter a wrong configuration. And when there is a change in the network, connectivity may be lost. Network administrators are responsible for pinpointing and solving problems. To find and solve these issues, a network administrator must be familiar with tools to help isolate routing problems quickly. So it means that a network administrator should know some common troubleshooting commands. And to use these troubleshooting commands, first we will show you a topology and how to demonstrate those commands. And here is a topology shown in the screen that we will use to do some troubleshooting commands. One of the troubleshooting commands is the command ping. The command ping displays the result of an extended ping from the source. In this case, it's an interface of router 1 to the LAN interface of router 3. And extended ping is an enhanced version of ping utility. Extended ping enables you to specify the source address for the ping packets. We have even the command traceroute, which displays the result of a trace route, here in this case from router 1 to the router 3 LAN. And remember that each hop route returns an Internet Control Message Protocol replay. We have the command show IP route, which displays the routing table, and in this case for the router 1. We have even the show IP interface brief, which is a quick status of all interfaces on the router by using this command. And here we have the status of all interfaces for the router 1. And another command that we can use is the show CDP neighbors, which provide a list of directly connected system devices. This command validates layer 2 connectivity. And here in this, for example, if a neighbor device is listed in the command output, but it cannot be pinged, then the layer 3 address should be investigated. So by finding a missing or misconfigured route is relatively straightforward process if the right tools are used in a methodical manner. For instance, let's use this network, and a user at the PC1 reports that he cannot access resources on the router 3 LAN network. This can be configured by by pinging the LAN interface of router 3 using the LAN interface of router 1 as the source. Again, we will use this topology to figure and to demonstrate how to troubleshoot the connectivity problem. So the first thing is to ping the LAN remote from the router 1. In this case, the network administrator can test connectivity between the two LAN from router 1 instead of PC1. This can be done by sourcing the ping from the Giga Ethernet 00 interface on router 1 to the Giga Ethernet 00 interface on the router 3, as it is shown here in the example. The ping results show that there is no connectivity between those two LANs. So what we will do, we will ping the next hop router. which means that we will ping to the serial 010 interface on the router 2, and we can see that it is successful. This ping is sourced from the serial 010 interface of router 1, therefore the issue is not loss of connectivity between router 1 and router 2. So what we will go and ping router 3 from serial 010. Which means that we will ping from router 1 to the router 3 interface 192.168.2.1, and we see that it is successful as well. The ping is sourced from the serial 010 interface on router 3, and router 1. Router 3 has a route back to the network between router 1 and router 2, which is 172.16.2.0/24. This confirms that router 1 can reach the remote LAN on router 3. However, packets sourced from the LAN on router 1 cannot. This indicates that either router 2 or router 3 may have an incorrect or missing route to LAN on router 1. So what we will do some verification, and we will verify the router 2 routing table by using the command show IP route, which begins with the gateway. So is the step to investigate the routing tables of the router 2 and router 3. The routing table of router 2 is shown here in this example. We can see that 172.16.3.0/24 network is configured incorrectly. The static route to 172.16.3.0/24 has been configured using the next hop address 192.168.1.1. Therefore, packets designated for the 172.16.3.0/24 are sent back to router 3 instead of router 1. So what we will do is we will correct the router 2 static route configuration. So we have to reveal incorrect IP route statement. The incorrect route is removed and the correct route is ended, which means we go to the router 2 global configuration mode and we use the no IP route 172.16.3.0 followed by the segment mask and the next hop IP address, which was incorrect, and with this, we will delete this route and we will add the correct route to the routing table by the command IP route 172.16.3.0 followed by the segment mask and the next hop. Then after we do this, what we will do is we will verify the new static route is installed, which means that we will use the command show IP route beacon gateway again, and we will see that the entry to LAN on router 1 172.16.3.0 is correct now as it pointing toward the router 1. And the next step after we correct the configuration is to ping again the remote LAN. And after we do the ping from router 1 source from giga000, we see that now we can reach the LAN network of router 3. So this was an example of troubleshooting IP static and default route configuration. And with this, we are ending our session for this video, and see you to the videos that will be uploaded on the future. Thank you and see you soon.